Thank you so much for introduction. So, I am Dr. Vikas Punia, Assistant Professor in the Center of Excellence in Water Management at Manit Bhopal, that is Maulana Azad National Institute of Technology Bhopal. And before starting my presentation, I would like to thank Dr. Surbhi ma'am and Dr. Jyoti Sharoop ma'am for inviting me and giving this wonderful opportunity to present my research work in front of you. So, thank you the coordinators and convener of this program, this Gyan course. So, this is my presentation and the lecture for this Gyan course on this climate change and urbanization. And the topic of this presentation is advanced methodology for intensified flash drought and its impact on terrestrial ecosystem across Indian river basins. So, in this lecture I will not discuss about the traditional droughts which we know from lot of times, that is meteorological drought, hydrological drought or agricultural droughts. We know all these droughts for so long, more than 40, 50 or 100 years ago. And mostly we have heard a lot of news about these droughts. And these droughts are known as conventional droughts, like meteorological, hydrological or agricultural drought. But recently from last 5-7 years we got a new terms related to this, that is a new type of drought, that is flash drought. Mostly we heard about flash flood, but before 5 years we have no keywords related to flash drought. But recently we discovered, some of the scientists discovered this new terminology related to drought, that is flash drought. So we will discuss about this lecture, that is advanced methodology. So in this we will discuss the flash drought and what the new definition we can propose. So in this we have proposed a new definition for this flash drought. So I will discuss all the things related to this. And this work has been carried out at ISC Bangalore and Purdue University, USA. So I am acknowledging both the institutes because when I am at a postdoc fellow at Purdue University, I have carried out this work. So I am acknowledging both ISC Bangalore and Purdue University, USA. So before going deep into the flash drought condition, it is very mandatory that we need to understand what are the current situation or current status of extreme climatic conditions over India. So if we talk about the floods, if we took the data or we can see the data set related to floods, what we found that more than 40 million people around the Indian subcontinent are affected by widespread flooding in last 2015, 16, 18 and 2019. Other than condition in India, what we found that India is witnessing consistent warmer seasons recently, and if we talk about the top 15 warmest year over India, we found that 11 out of these 15 warmest year are only from last 15 years, that is from 2007 to 2021. So from this itself we can understand what is the warming situation over India in last 15 years, because 11 of the 15 warmest years are from only last 15 years. It means 11 years of last 15 years are the warmest years across India all time. If we talk about the heat wave condition, then we get to know that if we talk about only of the 2024, 56 heat related deaths and 25,000 heat strokes, we have reported the cases against these things in India from March to May. Only in the 3 months we have 56 deaths and 25,000 heat strokes only in the 3 months of this current year. So this is the situation of heat waves across India. Other than that, if we talk about the extreme precipitation or extreme rainfall condition, a study has been carried out in 2017 and they found that more than 3 times increase observed in the rainfall events or extreme events in the last 65 years from 1950 to 2015. So looking at all these data set, we can say that due to large population and due to high economic activities across India, India is at high level of risk of disasters. Either it can be disaster related to climate, related to geology or related to human induced disasters. So this is the reason why we need to understand what are the climatic conditions or extreme climatic conditions over India. Why we have carried out this study? So we know that due to greenhouse gas emissions and increasing CO2 concentration, it leads to change in the climatic conditions. and due to human influence there is a change in land atmospheric interactions. And this combined effect of change in climatic conditions and change in land atmospheric interaction results in several impacts, like change in magnitude of precipitation, like decrease in the precipitation, increase in increase in temperature, decrease in relative humidity, soil water deficit or depletion of groundwater levels. And all these impacts will result in various possible extreme events like floods, extreme rainfall, droughts, atmospheric warming, heat waves, out of which my study is much more focused on droughts and specifically on the flash drought. I have find out all the droughts like meteorological, hydrological, soil moisture, vegetation drought. After that I found that during the drought condition there is a rapid decline in soil moisture, and this rapid decline in soil moisture leading to a new type of drought, that is flash drought. So let us understand what is flash drought. So recently we got a lot of news from different parts of India, different parts across the globe, that flash droughts are claimed as a new type of extreme weather event. Some of the study says that flash drought is new type of climate change effect. But the major thing which they found in one of the study which has been carried out at New England, that even the damp conditions are also hit by the flash drought. What we know from the drought, that mostly the droughts are hit by the droughts are hit in the arid or semi-arid regions. Mostly arid or semi-arid regions are more vulnerable to drought condition. But in this, what we found in the study, that some damp areas are also hit by the flash drought. Then some of the researchers also carried out future flash drought study, and they found that these future flash drought events are also increasing over the humid regions rather than arid or semi-arid region over the England. If we want to see the impact of flash drought, we are saying that it is an intensified flash drought and it is different from traditional drought. So how it is different? So if we want to visualize the effect of this flash drought, you can see the two photographs. These two photographs are taken by some research scholar in US in the time span of 41 days. The first photo is taken on 1st July of 2012 and second one taken on the 11th August. It means after 41 days. And we found, you can see the impact of the flash drought within 41 days. The condition of the greenery condition is converted into the red conditions due to flash drought within 41 days. This type of effect we can observe in simple traditional drought within 6 months or 12 months. And the same impact flash drought can give within 40 days. So this is the effect of flash drought. That's why it is suggested that we need to carry out more studies, and faster future forecasting of flash drought is required from all these studies we need to carry out. So let's introduce what is flash drought. So if we talk about India, India is one among the most vulnerable drought prone countries in the world, with at least one drought occur in every 3 years in the last 5 decades. But this statement is much more focused on traditional, or we can say conventional drought, like meteorological, hydrological or soil moisture drought. However, recent research revealed a new type of event or new type of extreme weather event which is termed as flash drought. And these are completely contrast to each other, because traditional drought are very slow growing climate phenomena. They can take few months, seasons, or sometimes they take full year in order to attain their maximum intensity or spatial extent. However, these flash drought are characterized by quick onset and rapid intensification. Quick onset means the onset or the initial stage of the start of the flash drought is very fast, and rapid intensification means the rate at which intensify at every single step is very high. Okay, that's why it is characterized by quick onset and rapid intensification, due to which it causes a quick reduction in soil moisture. And this rapid reduction in soil moisture gives you or leads to vegetation stress. So in this study we have developed a definition for this, because we have several 2 or 3 definitions for the flash drought, but these definitions have a problem that they are region specific definition. They cannot be used across different climatic regions. So what we have developed a new definition to define the flash drought, that is based on aridity index. So this is the first time definition developed by us. And the second thing, for the very first time in India, we have find out that flash drought impact on terrestrial ecosystem across Indian river basin, across different parts of India, was also investigated in this study. So these are some of the data sets we have used in this study. So first is the precipitation and second is the temperature, and both data we have taken from the IMD, India Meteorological Department. Since these data set at different resolution like 0.25 degree into 0.25 degree and 1 degree by 1 degree. Other than that, we need daily potential evaporation. In order to calculate aridity index, we must have daily potential evaporation. So the best data source for this is GLEAM data, that is Global Land Evaporation Amsterdam model, and it is also available at 0.25 degree into 0.25 degree. Other than that, we need wind speed and relative humidity. So wind speed we have taken from Princeton University, and relative humidity we have taken from NCP NCAR reanalysis dataset. Other than that, we also need soil moisture dataset. So the problem with soil moisture dataset that in India we do not have in situ or observed soil moisture dataset. Like precipitation, we have some rain gauge stations set up by the IMD, but in case of soil moisture we don't have like that. So what we have done in order to do the alternate option for the soil moisture data set, we have two options: either run the hydrological model like SWAT model or VIC, that is variable infiltration capacity, or second, we can take the soil moisture from different sources like European Space Agency Climate Change Initiative soil moisture combined data set, GLDS data set, ERA data set, modern ERA data set, or IMDA8 soil moisture data set. The last one is developed by IMD. This is India data source, that is Indian monsoon data assimilation and analysis version. This is also by the India, and if you are looking for any other data sets related to India, you can find the data source very easily at IMDAA. Other sources are on a global level and they provide different sources of data, not only the soil moisture, they will provide other data sources also. So what we have done, we have taken different sources of the soil moisture data set, out of which we will select the best one. Initially we will take all and we will think that all data sets are good, out of which we will find out the best one for our study area. Other than that, in this we have to find out the impact of flash drought on terrestrial ecosystem. For that we need to have some indicator for terrestrial ecosystem. So in this study I have taken GPP, that is a gross primary productivity as a terrestrial ecosystem indicator, and this data set has been taken from Modi's data set. The problem with this data set is that this data set is available at 8-day temporal resolution. Other than this data set, all the data set either available at hourly, 3 hourly or daily data sets. So if data is hourly available, 3 hourly available, we can convert into daily. But if data is available at 8-day resolution, we cannot convert into 1 day or 2 day, because initially it is at 8 day. So what we have done, we have converted all the above data set to the 8-day resolution. Why? We need to make the homogeneity in the data set, that all the data set should be at the same resolution, either it is spatial or temporal. So since they have different spatial resolution, so we have converted into same spatial resolution of 0.25 degree into 0.5 degree. Second thing, all the data set are converted into 8-day resolution, so that temporal as well as spatial resolution are same. Without having same resolution either in spatial or temporal, you cannot use the data set. Next than that, this study has been carried out over 25 major river basins of the India. These major river basins are classified by India Varis 2014 classification. So this study has been carried out over Indus, Ganga, Brahmaputra, Barak, Godavari, Krishna, Kaveri, Subarnekha, Mahanadi, Penar, Mahi, Sabarmati and all. So these are some of the river basin, and the short form like BB is Brahmani and Baitarani basin, EFR MGB is east flowing rivers between Mahanadi and Godavari basin, and all you can see from this presentation itself. So this is the study area where we have done the work, and this is the methodology. So initially what we have done, we have collected the data set from 1981 to 2021. Approximately 40-41 years we have taken the data set from the different sources which I have discussed earlier. Then we have computed the aridity index. So aridity index is a very simple computation. Simply you take the precipitation data and divide by potential evaporation. If you divide this, you will get aridity index. But this aridity index is not helpful for you to calculate the flash drought unless you will convert this aridity index into percentile values. simple absolute value of aridity index will not help you to calculate flash drought. So, if you are calculating the flash drought, first calculate the absolute value, convert into the percentiles. Once you convert the AI percentiles, then you can go for flash drought identification, in which I have 4 sub objectives. The first one is to find out the flash drought characteristics, like what is the frequency of flash drought, what is the maximum duration, what is the average duration, what is the severity of flash drought. The second thing is the intensification rate. At what rate flash drought are intensified? At what rate the flash drought are intensified? And the third is the triggers, or we can say in general terms drivers of flash drought. Means what are the variable which are causing the flash drought? And the second thing is, if flash drought occurs, so what is the hydrometeorological condition or behavior of the hydrometeorological condition during different stages of flash drought? Like before the flash drought, during the flash drought, and after the flash drought, how are hydrometeorological behavior variables are behaving, like soil moisture, precipitation, temperature, vapor pressure deficit, how they are behaving during the flash drought. Then how our ecosystem is responding to flash drought, and how water use efficiency or underlying water use efficiency is responding to flash drought conditions. So here one important term I need to discuss. I think all of you know somewhat about water use efficiency. Everyone heard about water use efficiency. That is, if we have a GPP data set, so GPP divided by evapotranspiration, we can simply calculate water use efficiency, and it is not a new term. So everyone knows about that. But I have introduced a new term, that is underlying water use efficiency. What is this? Whenever we have a data set for the water use efficiency, or if we are calculating the water use efficiency at very small time scale like daily or sub-daily time scales, then we must incorporate an important factor, that is vapor pressure deficit. And if we are calculating water use efficiency using vapor pressure deficit along with the water use efficiency formula, then that formula will convert it into underlying water use efficiency. Because whenever we are computing water use efficiency on an annual scale, you can simply use the traditional method. But if you are calculating this water use efficiency on a daily basis, on a sub-daily basis, on a weekly basis, then you have to include one important parameter, that is vapor pressure deficit, VPD. And if you are using that, then that water use efficiency is underlying water use efficiency. So once you have the aridity index, then you have to compute the aridity index percentile. Once you have aridity index percentile with you, then you can use this methodology to find out the flash drought. And please give some more focus on this slide, because this is all about the flash drought, how you can compute the flash drought. So what you have to do, you have to go for the 4 steps, and you have to check for all 4 steps. If all 4 steps are true, then only you can say that that particular event is a flash drought event, otherwise it is not a flash drought event. So what are the conditions? The first condition, that current aridity index percentile should be less than 50th percentile and prior should be greater than equal to 50th percentile. It means, for example, this is 50th percentile, so the aridity index value must come from above value to below value, from above 50 to below 50. If this condition is true, this is the first threshold condition, and if it is true, we can begin the flash drought identification and we can go for the second condition. If it is not true, we are not able to find out the flash drought. If it is true, we can go for the second condition, where we need to check that the mean decline rate of aridity index percentile should be greater than equal to 5%. Means this is the significance, or this is the indicator of rapid intensification. Means at every single step, the decrease in aridity index must be greater than equal to 5%. The decrease should not be very small, the decrease should be very high. So this mean decline rate of aridity index percentile should be greater than equal to 5%. It means it is showing the high intensification or high rapid rate of intensification. If this mean decline rate is true, we can increase the time count until unless this condition gets false. Once this condition gets false, for example, after 2 or 3 time step, first time step is first one, second this is true for 3 times, so total time is 4. Once it is false, we will go for the third condition, that aridity index percentile should be less than 20th percentile. And if it is true, we can increase the time count until unless it is get false. For example, it is true for 2 times and then it falls. So total time is 5 or 6. Once 3 conditions get satisfied, we will go for the 4th and the final condition. Then total drought duration should be greater than equal to 3 time steps. It means minimum these conditions should satisfy for 3 times minimum. If it is not, then we cannot say that is a flash drought event. If it is true, we can say that that particular event or that particular drought event is a flash drought event, otherwise it is not a flash drought event. Since we are saying 3 time step and 1 time step is 8 days. So 8 into 3 is 24 days. So minimum 24 days are required to happen flash drought. If we are saying that flash drought is happening in this particular region, so minimum it requires 24 days to happen. Some of the definitions take 5 days as a data set. So 5 into 3 is 15. So some of the definition related to flash drought on soil moisture are having a threshold of 15 days. So either 15 days or 24 days are the thresholds to have the flash drought required to happen. So this is the total methodology. In that we have 4 conditions and all 4 conditions should satisfy. Sir, no. Ma'am, we have developed this definition. Yes, ma'am.
So how did you came out with this criteria that it should be 3 times the rainfall liter?
Okay, ma'am. So the first thing that we have taken 2 thresholds, 50% and 50 percentile and 20th percentile. The reason is that we have aridity index classification for so long, 58 years back, and from there itself we will get to know that if aridity index value is less than this, then it is arid region, or if it is less than this, this is semi-arid regions. So based on that, we have defined these 2 percentiles. Once we have the aridity index absolute value, we have converted absolute value into percentile values, and from there itself we have given these 2 thresholds. Once we get to know, then we need to define these 24 days. So from the literature review, we have some definition related to flash drought based on soil moisture. So there are 2 definitions. If they are taking 5 days data, pentad data sets at a time, they are defining 3 into 5, that is 15 days. Some of the definition related to soil moisture is 3 into 8, that is 24 days. From there itself we have taken 24 days. Since our data is at 8-day temporal resolution, so we cannot use 3 into 5. Because for the terrestrial ecosystem, I have used this data set GPP, that is a gross primary productivity from the Moody's, and this is available at 8-day only. So we cannot use for 5 days. That's why we have taken 3 into 8, that is 24 days. Otherwise 15 days is also the threshold for this. Okay, so this is the flash drought methodology in which you have to check 4 conditions, and if all 4 conditions get satisfied, then only you can define the flash drought. Otherwise it is not, it can be a drought, but it cannot be flash drought. So let's discuss some of the results related to this. So before going to results of flash drought, we need to understand the climatological characteristics across India, so that we can correlate which area is having highly sensitive to flash drought condition, which is having high precipitation, which is having low soil moisture condition and all. So let's show the climatological and ecological characteristics of India. So here I am showing the spatial distribution of annual mean precipitation, soil moisture, gross primary productivity, water use efficiency and underlying water use efficiency across India. And we can see from the graph itself that annual mean precipitation of India is ranging from 3000 from less than 100 mm per year to more than 3000 mm per year. So this is the heterogeneity of India. In some parts we have high rainfall and in some parts we have very less rainfall. So this is the spatial and temporal heterogeneity of India across different river basins in terms of precipitation and temperature. If we talk about soil moisture, you can see that mostly very dry soil conditions are happening or taking place across central and western India. If we talk about GPP, water use efficiency or underlying water use efficiency, we can observe that maximum gross primary productivity or water use efficiency is concentrated over northeast India or western Ghat, and minimum is happening over some parts of western India like Rajasthan. And why this is happening? water use efficiency at northeast India or Western Ghat is very high because we know that these areas are covered with forests. However, if we talk about Western India, in these parts we have very low productivity and very high demand of evapotranspiration. So due to this, water use efficiency and GPP value are very less our Western or Central India. So we got some idea about the precipitation and all about India. Let's go for the flash drought. So here are the results for the flash drought. So here in this figure I have shown the seasonal distribution of flash drought frequency over different river basins of India in the last 41 years. So here I have taken 4 major seasons defined by IMD, that is winter season, pre-monsoon, monsoon and post-monsoon season. Winter season, pre-monsoon, monsoon and post-monsoon season are from Jan to Feb, March to May, June to September and October to December, and these are defined by IMD. You cannot define on your own. So whatever defined by IMD, we have taken that. But the thing is, some of the flash drought events start in winter and terminating into pre-monsoon season. So it is very confusing for us whether we take that event in winter season or pre-monsoon season. Some of are starting in pre-monsoon and terminating into monsoon season. So what we have done, we have created for another season, that is a transition from one to another season, like transition from winter to pre-monsoon, pre-monsoon to monsoon, monsoon to post-monsoon or post-monsoon to winter season, so that we can incorporate all the events, not in only the 4 seasons, but we can include in all 8 seasons. So from the results we found that during the monsoon season, majority part of the India is showing very low likelihood of flash drought events. In monsoon season we don't have any problem related to flash drought. But highest flash drought frequency are observed in post monsoon season. You can see from the figure itself, the post monsoon is highly red, that is having frequency greater than equal to 12. So the highest frequency is observed in post monsoon season, followed by the transition seasons. And why this flash drought is more in post monsoon season? Because in the post monsoon season or other than that, like March, May or transition seasons, because in that period we have long dry spells with negative precipitation anomalies, because in that seasons we don't have precipitation our India, and this long dry spells with negative precipitation anomalies causes rapid reduction in soil moisture, and this rapid reduction in soil moisture triggers the flash drought. Let's discuss the another part, that is flash drought intensification, means at what rate our flash drought is intensified. So in our definition we have used 5% threshold, but in some part it is more than 10%, in some part it is more than 20% also. So if it is more than 20%, obviously it will affect more than 4 times. So we need to check what is the rate of intensification and where it is very high. So what we found, that this high intensification rate is more common in humid regions rather than semi-arid regions. As a researcher, if we are working on a drought, what we know, that mostly the arid or semi-arid regions are more vulnerable to drought conditions, like Western India, like Rajasthan. But here what we found, that high intensification rate is more in humid regions. We are not expecting these results, we are expecting opposite to this. So why this is happening? Because these results are happening because anthropogenic climate change. This climate change has altered the traditional climatic regions of India, and if we talk about the flash drought, we need to give more attention to these humid or semi-humid regions rather than addressing arid or semi-arid regions. And why we can say that why this Western India is not in this category? Because in Western India, like Rajasthan, they are more vulnerable, they are more prone to traditional droughts, year-longer droughts. They are not confined with small period, they are confined for seasons, they are confined for year-longer droughts. That's why here we have flash drought our humid regions rather than arid or semi-arid regions. Next, we will discuss what are the major drivers or major triggers of the flash drought. So from the literature I got to know that there are some definition of flash drought which includes precipitation as a variable, some of the definition uses temperature as a variable, and some of them use soil moisture. So what I have done, I have taken all three: precipitation, temperature and soil moisture, because I don't have any idea that which one is the trigger of flash drought over India. So I have taken all three: precipitation, temperature, soil moisture, and the combination like precipitation, soil moisture, precipitation, temperature, temperature, soil moisture, or the combination of all three, that is precipitation, temperature, and soil moisture. We have no idea. We cannot say, okay, the precipitation might be, the lack of precipitation can be the trigger of flash drought. No. So we have taken individual triggers, combination of them, and the combination of all three. And what we found from the results, that majority part of India, you can see that precipitation plus temperature, both are acting as a major triggers. You cannot take individual triggers. Precipitation plus temperature are the major triggers across some parts of most part of the India. However, in some parts like Western Ghat and Northeast, you can see the individual effect of soil moisture and precipitation. It means if you are planning to give some policies, or if policy makers are making some policy related to flash drought, and if they are making for Northeast, they should think about that soil moisture is the major trigger. If they are making for the Western Ghat, then precipitation or lack of precipitation is the major trigger. Otherwise, other than these areas, majorly the precipitation plus temperature are the major triggers of flash drought. So if you are going to conduct any study related to flash drought, you should consider precipitation and soil temperature as the major triggers of the flash drought. And if you are also developing any definition, you can use these two parameters. Then we have calculated the flash drought. Then we need to find out that during the flash drought, how our hydroclimatological variables are behaving, because this is the definition developed by us. So we need to have some validation, otherwise might be our definition is wrong. So what we do, once we calculated the flash drought, we will calibrate or we will validate our results with the variables, that is hydroclimatology variables like soil moisture, precipitation, temperature, vapor pressure deficit, how they are behaving during the flash drought. Yes.
Last time, in this we do not consider the physiographical parameters like slopes.
No ma'am, that parameters we are not considering, only the climatological variables we are taking. That thing we can include, but here in this study I am only including the climatological variables. Yeah, that can also, like altitude, everything can affect, because every single thing is affected by a lot of things. But we cannot take all the parameters at same time, but we can include in the future study, that is like slope or the shape of the basin and the altitude of that particular area, we can include that thing. Okay, so other than that, we need to understand whether, yes. Okay. Yeah, I have three conditions to find out. I'll share the paper with you. In that, I have given the stats that if precipitation anomaly is less than 40% and temperature is like that, then precipitation is only the factor which affects the flash drought. Other than that, I have think that if precipitation is less than this and temperature is less than that, then precipitation plus temperature are the triggers. So I will show. I will later share the papers. These study have been published in two papers. I will share both.
I also had this doubt that why temperature is not significant in Northeast as you said.
Okay, because ma'am, when we check the stats with that conditions, that anomaly is not less than that thresholds, and they are defined by literatures. So I have taken from the literature that if we are defining any flash drought condition based on the temperature, because we have definition for precipitation, temperature and soil moisture as a variable for the flash drought. So we have taken their definition. If they are defining lack of precipitation for the flash drought, what should be the condition for lack of precipitation? If they are defining a flash drought based on high temperature condition, what are their conditions? If these conditions satisfied, then we can say yes, this temperature can be a trigger for this.
Who are defining?
Different literatures across different parts of the globe. So because they have taken these three parameters, so I have taken all three. Okay. Yes.
You were saying that it was surprising the regions with high humidity are also, you are calculating that there might be flash drought. So like the literatures, so why didn't you go for transpiration instead of just evaporation?
Because the aridity index calculation or aridity index formula is potential precipitation by potential evaporation, and aridity index itself is widely used for to define the arid and semi-arid regions. That's why aridity index we can use. So whatever the formula aridity index have for so long for 50 years, we use directly that formula. After that we have calculated the percentiles. Before that we have not changed any definition. Whatever the formula for AI, that is aridity index, we have taken for that, and whatever the classification for arid, semi-arid and humid and semi-humid, we have taken directly from that formula. After that we have calculated the percentiles, and based on that we have defined this definition. Okay, so triple collocation. So in this approach we have used to find out the best soil moisture data set. So in India we don't have any in situ or observed soil moisture data set. So we have taken the soil moisture from different 5 sources that we have discussed earlier in the data set slide. So we have taken all the data sets from different sources, and we need to find out the best soil moisture data sets, because these data sets are from different models, and all the models have some uncertainty associated with them due to different model structure and different inputs. So I have applied this triple collocation approach. In that, what is the use of this triple collocation approach? That sometimes we directly use some of the data source directly for soil moisture, but we are not confident enough whether that data source is best for us or not. So in this triple collocation, what we do, we will take different sources of data set. For example, if you want to check the IMD data source for precipitation, you take different data sources for precipitation like IMD, ERA and different one, and then you make the triplets. You can see from all the figures, at every single row we have only 3 data set. That's why it is triplets. And in this triplet, for example, if you are taking the first row, you are taking 3 data set at a time, out of which you are not confident enough which one is the best one. So you are not claiming that IMDA is the best one or GLDS or MERA2. You are taking all 3 as a wrong data set. Might be any one of the correct, but you are not sure enough. So what you do, out of all 3, you will create an unknown truth. Against this unknown truth, you will calculate the RMSE and correlation coefficient value for all 3 data sets at the same time. So you are not treating any one of the data source as a perfectly observed truth. You are creating unknown truth from that triplet, and with the help of that unknown truth, you are finding out the RMSE value with IMDA, then GLDS, then MERA, then some other things. And finally, based on the best RMSE value and best correlation coefficient value, you will find out the best soil moisture data set for our study area. So from these results, what we found, that GLDS and ERA data set are performing better as compared to other 3 data sources. But however, we have to take one. So we have taken GLDS data set, because GLDS is performing slightly better than ERA data set, and some problem with ERA data set is that there are some missing data set in ERA. So due to that, we have taken the GLDS, and from here itself, whatever if we are taking soil moisture, that is from GLDS, not from other sources. So let's define whether the definition developed by us is validated by climatological variables or not. So we have to find out whether these climatological behavior, how they are behaving during different stages of flash drought. So we have defined 4 stages of flash drought. Means before the flash drought, that is onset minus 8 days, means before the start of the flash drought. Then onset and recovery of the flash drought, and finally after the termination of flash drought. These are the 4 stages. So what we check, if we talk about the soil moisture, what we see that before the flash drought, soil moisture is nearly approximately 50 percentile, means the soil moisture condition is well suited for the normal condition. There is no problem with the soil moisture condition. But once it enters into the flash drought condition, it declines from 50 percentile to 41 percentile. And if we talk about to the last stage of the flash drought, it is showing a quick transition to much drier condition, and from 50 percentile it reaches to 90th percentile. So this is the rapid reduction in the soil moisture, and this will cause flash drought, and after the termination this soil moisture condition recovers very quickly and it reaches to 36 percentile. So if we talk about our definition is highly validated by soil moisture condition, that during the flash drought the soil moisture condition is very less, from 50 to 90th percentile, and after the termination it recovers very quickly and reaches to 36 percentile. If we talk about the precipitation or temperature condition, you can see that if we talk about the during the flash drought, the precipitation condition, the precipitation value are very less, shown by the red graphs, and before and after the anomaly or standardized anomaly of precipitation are green. It means before and after precipitation is very high, but during the flash drought it is very less. Similarly with the temperature condition, that during the flash drought the temperature condition are very high, vapor pressure deficit condition are very high, but before and after it is very less. So if we talk about these hydrometeorological conditions, we are sure enough that our definition is correct, because soil moisture is also behaving in a similar way, precipitation also behave in a similar way, and temperature also behave in a similar way, and these are the major triggers of flash drought. So all are behaving in a best suited possible way. So we can say yes, our definition is correct. Then the last part is ecosystem response, that how our ecosystem is responding to flash drought. For that I have taken two parameters to find out whether our ecosystem is responding to flash drought or not. The first one is response frequency and second one is response time. Means how frequently our ecosystem is responding and after how much time our ecosystem is responding. For example, in some part of India flash drought is happening and there is no effect on ecosystem, then response frequency is 0 and response time is very high. So there is no problem, our ecosystem is highly resilient and there is no response from our ecosystem. But if our ecosystem is responding, it means that is very highly critical condition for that particular study area. So let's have results for that. So these are the results related to response of ecosystem. So first one is for response frequency and second for response time. So in case of response frequency, we are not able to get any substantial difference across different part of India. So we are not discussing that. But in case of response time, we found that some part of India like Northeast India or Indo-Gangetic plains are showing longer response time. And longer response time means our ecosystem is not affected for so long. And this longer response time is good for us because this longer response indicates the lower risk to the ecosystem. If we are showing response very quickly, then it means we are affected very easily. And if we are responding after so much time, then it means we are still at lower risk and we are responding after very long period of time. But the problem is that we are not able to get when our ecosystem is responding or when our ecosystem is not responding. For that we have calculated the response of water use efficiency and underlying water use efficiency to the flash drought. And here we have calculated for two conditions, onset season and recovery season. It means initial stage and final stage of flash drought. And what we found, there are two important findings in these results. The first one, that underlying water use efficiency values are always higher as compared to water use efficiency value. Why? Because in this we have included an important parameter, that is vapor pressure deficit. So that's why this value are always higher, and these are correct value whenever you are calculating the water use efficiency value at daily scale. Water use efficiency is not the correct, underlying water use efficiency is the correct formula whenever we are calculating water use efficiency at daily scale. If you are calculating at annual scale, then you can compute water use efficiency, no problem. Second important thing, that in case of onset stage, the water use efficiency values or underlying water use efficiency value, their magnitude are high. But this magnitude decreases in recovery stage. It means initially our ecosystem is not responding to flash drought. Initially we have high value, it means our ecosystem is showing high resilience to the flash drought. But this resilience or this adaptation to the flash drought condition decreases with increase in the flash drought duration. If the flash drought duration is more, this adaptation, this resilience power of ecosystem is decreasing with increase in flash drought durations. So based on these we can conclude that aridity index can be used as an effective indicator to define the flash drought. So this definition you can use in the future for your studies if you want to define the flash drought or you want to work on the flash drought. The second thing, then high intensification rate of flash drought are more common in humid regions rather than semi-arid or arid regions. So whenever we are making some policy regarding to flash drought, in spite of droughts condition, then we need to give more focus on humid or semi-humid regions rather than arid regions. If we talk about the triggers of flash drought over India, the precipitation plus temperature are the major trigger across India except Western Ghats and Northeast India. And if we talk about the ecosystem response of India against the flash drought, we are highly responsive to flash drought, that is 97% of flash drought events are responded by our ecosystem. And other than that, from the last slide we got to know that our ecosystem is highly resilient to flash drought, but this adaptation or this resilience power is decreasing with increase in flash drought duration. So if flash drought duration is more, it is not good for our terrestrial ecosystem because our ecosystem is not resilient enough to handle the flash drought with high durations. Other than that, in this study we have used top 1 meter soil moisture data set. So after carrying out the whole study, I found that some of the plants have roots deeper than 1 meter. So it is a confusion for us whether this study is useful for that crop or not, because some plants have root deeper than 2 meter and we have taken the data of soil moisture up to 1 meter. So whether it is applicable for them or not. So I have carried out this study again for 2 meter soil moisture data set, and what I found that results are very similar to 2 meter or 1 meter. They both are same. So from this also we can suggest that you can use a 1 meter top 1 meter soil moisture data set blindly, no problem with that, and that is applicable to 2 meter root joint soil moisture roots crops also. So based on these, we can say that these results are very helpful to policymakers to develop effective flash drought risk mitigation, reduction and mitigation strategies across Indian river basins. So these are two publications. The first one is in the Journal of Hydrology, that is terrestrial ecosystem response to flash drought over India. And the second one is spatio-temporal characteristics and triggers of flash drought across Indian river basin in India, that is in Journal of Hydrometeorology. So I will share both the papers with ma'am, so they will convey you. Okay, thank you. If you have any doubts, please let me know.